Okay, so in yesterday's session, we discussed about basic compilation and then what is the use of Golang. What are the use cases that Golang suffice? These things we discussed in yesterday's session. So today's session, we will go and we start creating variables and stuff like that. Before going to do that, we will also have a look at it, basic environment variables that are going to be used in Go, etc. The IDE that you have to use to work with Golang is I use Visual Studio Code, which is widely accepted, and then many people use Visual Studio Code. And going to install Golang, go.dev, go to the website called go.dev, and then you just download Golang. Once you download the Golang, it downloads, and if you are on Windows, then wizard type of installation will be there. Even for the MacBook, there is a wizard type of installation. You just click next, next, and all it gets installed. Uh, okay, that's what you do with. That's how you install Golang, Go.dev, and please also install Visual Studio Code. You know that where to install Visual Studio Code. Download Visual Studio Code. You go here, download Visual Studio Code, and all. That's fine. Well and good. You can download Visual Studio Code as well. I'm not spending time assuming that, you know, considering that you can install Golang and Visual Studio Code. Both has to be installed. Go to go.dev, install, download Golang and install it. Even for the MacBook, Linux and all, there are instructions. Very clear instructions are there. It is to download and go to search your search engine and then type Visual Studio Code download. Then here it takes you to the Visual Studio Code download. Again, the download wizard download page takes you to different kinds of downloads. We are using Mac. Here you go. Again, you are using Apple Silicon, that means ARM chips, M1, M2 chips. Here you got to install it. You are using old Intel chip of MacBook, then you have to install. Click on this. Dep Debian package or RPM, like Red Hat, Fedora, SUSE, CentOS and all. I think it is RPM. If you're using Ubuntu or any Debian distribution, you can click on this step, and there are some instructions how to configure and set up the environment variables. Again, Windows. I don't think there are ARM systems in Windows. Maybe old Windows. I don't know. I think Windows there are only AMD chipsets. You can go and install, download. Whether you can use CLI installation, zip or installer. This is where system installer, user installer. I just click on this and then it would be next kind of an installation. It's pretty easy to use. Once you download and configure Golang, there is nothing specially you configure. If you're using Windows or MacBooks, it's pretty easy. It gets configured automatically. Uh, I go to Visual Studio Code. What I do is I create workspace. I go to training. I create a directory called Golang personal 2. Okay, Golang personal 2 is my training. Here, what you have to do is this is the directory I open. I go to Visual Studio Code, open add folder to the workspace, and I go to my workspace. Uh, I go to training, Golang person 2 training. Here you go. This is my workspace. What I do is usually I create a directory. Let us say this is the first demo, uh, mkdir one demo, one demo. I am inside one demo. Here you need to create a Go module. That is what actually you need to create a Go module. There is a module system in Go. From Go version 1.11 onwards, you can use modules. Module is Go mod is kind of a package manager. It maintains the dependencies for your project. It acts as a package manager like npm, poetry, pip, maven, gradle, NuGet in .NET. Like that, there is a package manager. Even GoMod is more than package manager. It's pretty lightweight, pretty easy to use. Any project that you are creating, you go into the project and then say GoMod. In it, give a name. Module name. Generally, module names are given as the your GitHub paths. GitHub paths are the module names. Generally, people give GitHub path as the module name. I can give it as demo right now. You see that there is one module file is created. Module demo, which is called Go 1.22.0. This is the module name. Cool. The starting point of your Go application, for that you need to have a file code main.go, or code is a command of Visual Studio Code. It creates a file if the file is not there. It opens the file if the file is already there. Code main.go. Okay, if you want to install code command, click on Control Shift P or command palette. Here, code install code command and path. Shell command install code command and path. If you install this, automatically whenever you put code, the code is created. Code main dot. Let's say that I say code main.go, it gets opened because it is already there. If it is not there, it is created. You know that in Visual Studio Code, if something has yet to be saved, that this white color circle or sphere, whatever it is there, if you save it, it is disappeared. Okay. First line of your code is package main, because it's a compiled programming language. Compiled programming language, the compilation, the execution starts from main. In fact, the execution from the developer's perspective, the execution starts from main. From the Go runtime perspective, there is even uh, detailed information. Actually, main package is starts the main package, and internally it does a lot of stuff, and ultimately it reaches a place where main is the package name, dot main is the function name, function main. This is the starting point of your Go application. Package is a keyword, func is a keyword. These two are keywords. There are 25 keywords in Go. Already two keywords we used. This is the starting point of your application from the developer's perspective. That means your application starts executing from here. Okay, your application start executing from here. Really from here, not really from there. There is another steps before main. There are certain things happen, but assume that this is the starting point of. For now, keep it as this is the starting point of your execution. I want to print something. There is a built-in function. There are built-in functions in Go. Functions that are built-in. Built-in are very few functions. Functions are methods from the packages. There are many. There is a standard package of Go. In the standard package, there are many functions or many methods. But built-in functions, there are few built-in functions like print line is a built-in function. What it does, it prints hello world. So the main function must be inside main package. The main function must be inside main package to consider it as a main function. Without main function, there is no binary. You cannot create an application that is a binary application without main function. That's a must and should. You should have a main function. And the main function must be inside a main package. The name of the file not necessarily be main.go. It could be anything. Let's say it can also be hello.go. No problem. Absolutely, there is no problem. You can have hello.go. File name could be of anything, but the package name should be main. If it is a binary application, you are going to generate a binary. It's not a library. I mean to say it's not a package or a library. If it is a package or library, you don't need main. but it is a binary, you need to have a main function. Main function must be inside main package. For example, here you create multiple functions. The main package can be split into multiple files. Each package not necessarily to be in one file, unlike many other programming languages. In Go, each package not necessarily be in one file. Let's say package main. It's a predefined package like function main. For example, I create another functions here. This is a function called greet. This is inside the main function, package main. I can create another file. I can call keep the package as main, and then I can put the function over there. And I can call the function called greet. It will be called actually, there is no problem. Package main, function greet, and then I can call the function called greet. Keep this aside for some time. Just to tell you that you can, I'm sorry, this should be inside demo, it's outside of the demo. Okay, this keep it aside for some time. I will show you little later while you are compiling. Cool. Now what I do is, I want to run my application. There are two things. You can build your application or you can run your application. Let me create a file called readme. How to run your Go application. To run your Go application, go run main.go. If main.go is the file name. Here the name of the file is hello.go. So go run hello.go. This runs the file. What it does, you know that we already studied some kind of compilation steps. It compiles, and then it creates a object file. There is an assembly code, and then it creates an object file. From that object file, there is a linker. That linker links, and then it creates a binary. The binary is created somewhere in a temporary directory. I think there is something called work directory. This is where actually the binary is created, in this particular directory. And then that binary is called over here. Whenever you say go run, what go run does, when you write go run, it compiles, assembles, and links, creates a binary in a temp location, and that binary is executed. This is what it does. It compiles, assembles, links, and creates a binary in the temp location, and that particular binary is executed whenever you call go run. Generally, what you do, you can go build it. You can say go build. That means you are building a binary. Go build is you are building a binary. Go build hello.go. It creates a binary with the name called this file hello. This is a binary. That means you can run that binary. That binary is run. It doesn't create in the temp equation go build. It doesn't create in temp location. Go build doesn't run create in temp location. Let's say that okay, you can run that hello. In Windows systems, it would be hello.exe. You can directly run hello.exe. Fine. This is a binary. You want to see the size, dush hello 1.3 MB is the size of the binary. 1.3 MB is the size of the binary. In fact, you can bring down the size of the binary because it is for the debug information. You can bring down the size of the binary. How can you bring down the size of the binary? There is something called LD flags in Go. No, you can say Go build LD flags. I guess the flags should be W and then S. These are the flags that you have to use. The output file could be, I can give it as demo1. The output file is demo1. From which file? From hello.go. See that where demo1 is created here. When you look at du demo1, you see that it is only 892 KB. That means of almost 30% has been striped down. So if you give LD flags, to go build, stripe down the binary, you can use those LD flags. It stripe down the binary. Okay, it stripe downs the uh, binary. So the output file is what actually you want output. Here we don't give this output, automatically the hello is created. Here we are specially telling that I want to name the output as separate output. I want to give the output as separate output. That's why you give output file. Okay, fine. Whatever I did it file hello. This is file hello. File is a command. I just hello, that means this file. I opened it. This gives me information that this particular binary is created for MacBook, Macintosh OS, 64-bit executable for ARM 64-bit architecture. This is what you are using, 64-bit ARM architecture. Okay. You can also cross compile. In order to cross compile, Go comes with something like Go arc environment variables. You can say Go env. See that a bunch of environment variables. Forget about all the variables. We will discuss few of them going forward. Better not to go and go through each and everything right now. We can go with this environment variables a little later. Okay. Now, what I do is there are two environment variables which are very imperative. One is called Go environment variables. One is called Go arc. It tells the architecture, underlying architecture. Processor architecture. That means it could be 32-bit or 64-bit, ARM or AMD, etc. And the other environment variable is Goose. Some people, actually it is called GoOS, people pronounce it as Goose. Goose talks about the OS, operating system, operating system. It could be Windows, Darwin is nothing but Apple. It could be MIPS, it could be Linux, it could be iOS, Android, etc. Even WASM, there are certain things. These two environment variables are very important for cross compilation. Now I would like to cross compile and build Go applications. What I have to do is, first I need to list down what all, you need to know that what all actually operating systems and architectures that it support. Go has a tool called Go tool. Dist is the distribution list. Go tool dist list. That means to check supported OS and architecture. What tool you have to use? Go tool dist distribution list. This gives you all the list of OSs. These are the OSs that it support. AIX, Android 386, that means 32-bit normal Intel based machines. AMD, Android AMD, there are very few devices still supports Android ARM and ARM 64. Darwin AMD means old MacBooks. Darwin ARM 64 is a Mac M1, M2, M3, M4 chips. Dragonfly is an operating system that runs on AMD. FreeBSD, OpenBSD are very famous operating systems. Let's talk about FreeBSD. iOS, this is for the WebAssembly latest WASM, and then WASM JS is the operating system. WASM is the architecture, and Linux, different versions and variations of Linux. NetBSD and Open. I think NetBSD is used in MacBooks, underlying operating system. OpenBSD is another kind of operating system. Plan 9, you know that. Solaris, WAPI, WebAssembly interface. Windows, different versions of Windows. The first one is, one minute, I'm just checking. I think this one, yeah, this is Linux X S 390X is nothing but what is that? Mainframes actually. 390X is mainframes, because I was giving training for some two guys who already worked on mainframes. So for them, actually, I showed this demo. Linux is the operating system, and this is the architecture. Fine. So this is the bar you get from this bar. The first one is the OS, and the second one is this got out. The first one is the OS, and the second one is the architecture. OS and architecture. Now I would like to compile my application, cross compile the application on Windows, to Windows. Let's say MD64. You go to Windows, these are the variations: Windows 32-bit, Windows 64-bit, Windows ARM. There are Microsoft Slate or something like the Surface were there, ARMs. I don't know still they are there or not. ARM 64 is 64-bit ARM. What you need to do is go OS equal to Windows and go ARC equal to what architecture you are targeting. I am targeting to AMD 64. AMD 64. Go build The output file is, I put it as hello.exe from hello.go. This is a cross compilation. This is how you cross compile Go applications. You are on a MacBook, I am on a MacBook, but I am cross compiling it to Windows. In fact, I can also cross compile it to Linux or Android. Let me check it as Android, and I give it as ARM64. Instead of exe, I give hello Android. No, this is Android. You can also do for iOS. I give a different name as iOS. ARM64, but the operating system is iOS. I can create something called a directory called build, and I can do all these things with the build directory. I got everything in the build directory. I created a directory called build, and okay, this is how you can cross compile your applications. If you go and open this, I go to build directory, file hello Android. I think it was, yeah, hello Android MacBook. I'm sorry, this has compiled to MacBook. I think I might have given something wrong with Android. You'll see that. It is giving us actually. Okay, let me check with hello iOS. Hello.exe. Okay, I think there is something went wrong. The command itself might be wrong. Wait a minute. Goose equal to Windows. Let me have a look at it. Windows AMD64. AMD64. Go build. Output is build hello.exe, and then I would like to build for hello. I'm sorry. So this is for Windows. sh du sorry, file build hello.exe. You can see that this is for the MS Windows. I think I shouldn't give this. This is for the MS Windows. Executable console 8664 for MS Windows. Let me do the same thing for Android. I put it as Android, and over here it is, I put it as ARM64. and I put operating system as Android. Generally, Android is considered as, so this is for Android. You can see that ELF 64-bit Pi executable ARM architecture version 1 more dynamically linked interpreter linker 64 go build whatever it is. It is not strict. Nowhere it's said as Android, but it is compiled for Android ARM architecture. This is dynamically linked. One thing that you have to keep it in your mind, that this is dynamically linked. It's not statically linked. And the reason might be some of the dependencies that are not available, which are for Android. And then I go here as iOS, and I put as hello iOS. Sego is not enabled, something it's not building for iOS because uh, it requires external linking, Sego linking. Sego is not okay. What it's telling, Goose is iOS. I have to check whether there is iOS or not. Yeah, there is iOS ARM64. There is Goose is iOS, and then architecture is ARM64. Go build. Sego is not available. Requires external Sego linking. It is expecting to cross compile to iOS. It is expecting some dependency. Okay. Uh, I think it requires some Xcode kind of a dependencies. You have to go and then install some Xcode dependencies for that. We give, let's enable Sego enabled one. Sego has to be enabled. There is something called Sego enable. Uh, I think there are some dependencies. However, we'll check it. Sego enabled one, and let's try like that. Yeah. Once I enabled Sego, Sego is a dependency of Sego. You have to. It's asking me to enable Sego because by default Sego is Go env. By default, oh yeah, now Sego enabled as one, but while compiling, it is expecting me to enable Sego. So I open file, build hello iOS. So it is also Mac OS 64-bit executable ARM64 because iOS and Mac OS, that is how it shows the dependencies. Like that, you have to cross compile your Go applications. Okay, that's how you have to cross compile your Go applications. There may be some dependencies required. You need to check why those dependencies are required, and then sometimes you may have to add those dependencies. You can have a look at the size, and then you can shrink down the size. That also you can do. If it asks for Sego, because there are some operating system dependencies sometimes, particularly iOS and all, at that time you have to enable Sego. Sego is also an environment variable. Sego is an environment variable. Any questions you have? Basically, what is Sego? Sego that allow Go packages to call C language code. So whenever you enable Sego, what happened? Go interoperable with C language. That means IO is expecting to call some kind of C language libraries whenever you develop something for iOS. So it is asking you to enable CGO. So whenever you enable CGO, your Go code can call C language code. Actually, by default, CGO is enabled. I don't know why it was again expecting me to enable CGO, but basically CGO is enabled. If you go look at it, Go env, CGO is enabled. However, yeah, that's fine. This is how you can cross compile your Go applications. Okay, now fine. These things are fine. What I do is I create a GitHub, and then we'll push all the code to GitHub. Golang training personal 2, Golang training. It's a public repository. I enable this repository. I would add this. Sorry, I would add this remote path. I say git init. I enable this. Git add, git commit, git push. Got pushed. This is the repository name. Just a demo and some certain things are there. This is the repository name. Have this repository. This is the repository name, public repository. Okay, cool. Now coming back to the other thing, I am deleting this. Okay, even in here, I would like to delete this. This got to be the output. I don't know how it comes. Okay, I deleted this. This also I delete. This also I delete. Okay, gitaram. There is no build directory, right? I'm sorry, even the readme was deleted. I'm going to delete readme file as well. When I set it up, then I just need to say push. Here you go. Yeah, yes, that's fine. So that is the now see that greet is a separate file. I can also call greet from here. It considered it as locally called, but the main is split into two files. If you really look at it, main is split into two files now. So how do you compile it or go build? Then sorry, you say go build. You need to tell which file you got to build. So hello.go and then greet.go. You need to tell that which file you got to build. There are two files to be built. So hello world and hello there. Hello there is called by this greet. You can give even small letter, not necessarily to give low capital letter because it is a. I'll tell you about that later on. Go run hello.go. You can say go run dot. It combines everything and run. Go run just a dot. It combines everything and run. Okay. So like that you can split it into many files. It's not necessarily that you need to call it only with one file and stuff like that. You can split it into many files and all. You can also compile. You can also compile by yourself. You can also do the compilation generally. So Go tool, you see that there are so many tools in Go. ASM, CGO, compile. Compile is one of the tools. You say when you type Go tool, obj dump is going to create object dump, profiling, tracing. Go tool, compile. Go tool, compile. The output would be maybe hello.o file, object file. When you compile it, it converts it as an object file. From what? From hello.go and then greet.go. You see that the object file is, this is actually the step-by-step compilation, but we just use go build or go run directly. Go run is to run the application for the developer. Go build is to build a binary and then put it over there. But you can also compile and then create an object file. This is the object file. This is the object file that is created. This is the object file that is created. Once you have this object file, what you need to do, you need to link it actually. For linking, you should have a linker. Okay. Go tool contains a linker as well. Go tool link. What to link? You link the object file hello.o and what you do? Sorry. You generate a file hello1. From what you generate a file? From the hello.o. From hello.o. Go to link. Go to link. You put it as output as the actual binary. From where you put hello.o object file. But I think there is some dependency issue. Unable to find runtime.a. So it is saying that unable to find runtime.a. Generally, you have to give go route and then go path. Everything is correct. I'm trying to remove all the Go module cache. I don't know. This would solve the issue because there is some issue with the configuration. Generally, Go tool it has to link. Uh, just let me check whether Go to link is there. Yeah, Go to link is there. There is no problem with the Go to link, but there is certainly problem with the mm, output file. Unable to user Go link package, user local Go package, cannot open hello.o file, no match for a directory. Uh, sorry, I think there is no file. I deleted it. First of all, let me go compile hello.o file. Now I have O file. Unable to find runtime.a. There is some issue with the dependency issues is there. I will check that issue and then we will solve. I will come back with because there is some dependency issue with Darwin ARM link. There is some problem with the Darwin ARM local Go package tool. I think it is unable to find this particular file, that particular location. I guess the link. Sorry. However, you can go and then you can link manually. You are it's able to create hello.o. Okay. Usually there is also a linker. I think hello.o output platform not specified or not specified. No, I have to check that LD tool also you can use. Basically, you can also use LD tool. I'll come back with that. LD, you have no platform minimum version. Okay, you have to use LD file. You need to see how to use LD file because LD is nothing but linker. Go compiler itself contains actually tool with that. So I compiled it. Generally, the link go to link can do it. That 1 minute. So Darwin ARM64 link. This tool is missing actually in this. Go to user local go pkg tool. This is the tool. This is the tool. The tool has to call. I'm just checking. That's directly with the tool. Interestingly, this is created over here. I'll tell you. Okay, this is the tool. Actually, this is the location of the link tool. This link tool, what I do is, this is the object file that is created with the compiler. This is the target directory. I can give it as target directory as this one. Okay, there is no build directory, right? You see that with this link tool, directly link tool, the link tool is where is the link tool? The link tool is in Go location. I directly link with the tool, the link tool directly used. I called hello here. This is the hello. So how it linked? It linked the compiler object file. It linked with hello. That means I go here. Because the link file is created, but hello file, but it is not in executable condition. Chmodx hello x chmod 777 hello. Now I run hello. There is some issue with the architecture. However, there is some issue with the architecture. Current or archive. There is some issue with the architecture. Current or archive. Okay. It has linked, but it has not linked everything, whatever is required, since we use direct link file. However, I will check that and then explain that. So this is what about uh, how to basically compile your Go application, cross compile your Go application, cross compile on different architectures. These are the commands how to use for the cross compilation and etc. In the next session, what I will explain is I will explain about this link. Actually, there is some issue with the dependency that I will solve and then show it to you. There is some issue with the dependency. some dependency tool. You can compile and create object files and then link them as well. I also show if at all possible with the LD file directly, LD executable, which is link executable. Fine. We will look into creating variables, assigning values of the variables, creating constants, conversions. These things we will discuss in the next session. Okay, I think that's what for today. If you have any questions, please ask. Otherwise, I will close the session. Any questions you have? I think if you are speaking on mute.